yesterday we started with a new chapter, that is matrices. Just I'm giving you glimpse of that again, and then we'll start with a new topic as well. So matrices. Okay. Yesterday I told you that it is nothing but rectangular array or arrangement of numbers or function. All right. So we use this kind of brackets, I would say. It is not actually a bracket, but I am just saying it in a simpler language. All right. And one thing I told you, that we will always denote it with a capital letter. So now suppose this is 1, 2, minus 1 and 0. This is a matrix. And I told you to write the order here. How many rows are there? 1 and 2. 2 rows are there. How many columns are there? 1 and 2. 2 columns are there. Horizontally rows, vertically columns. First we write row, second we write column. This is just a way to do it. So, and yesterday I told you about A11, A22, A33, these kind of notations also I told you. So now today I am just telling you how to write a matrix. Suppose if a question is given like this, Aij, and this bracket is kind of given to you, and suppose order is given as M cross N. So this is the way to write a matrix. This means what? Elements will be of the form A11, A22, A33 and up to so on, like A12, A13, up to so on. So it will go like this. A11, that means first row, first column. How many columns will be there? Yes, N columns will be there and M rows will be there. So A21, that means AM1, because M rows has to be there, and this I am talking about the first column only. Similarly, A12 up to so on, last element will be A1N. Why? Because this is the first row and this is the last column N. Okay. A22 and up to so on, A2N, up to so on, last element will be AMN, because this is mth row, nth column. This is just a repetition. We'll discuss today more things. It is not about only the representation, how we write the matrix and all that, but of course basic things you should know actually. All right, and yesterday we did types of matrices also. So many matrices were there: scalar matrix, diagonal matrix, identity matrix, and yes, identity matrix is also known as unit matrix also. Okay, where I mentioned no identity matrix. Identity matrix was of this kind of 1, 0, 0. That means all the diagonal elements has to be 1. This is nothing but identity matrix. Identity matrix is also known as unit matrix. Okay. Null matrix, zero matrix, both are the same things only. And many more ways. Column matrix, row matrix, these kind of things. So next, today I am going to do one more type of matrix that is known as, either it will be upper triangular matrix or it will be a lower triangular matrix. As the name is depicting itself, suppose if I'm talking about upper triangular. Okay, suppose if I'm talking about upper triangular means upper numbers will be there. Suppose A, B, C. These are the diagonal elements, 3 cross 3. Of course, I'm talking about square matrix here. Alright, suppose D, E, F. That means these elements are already there. Can be like, not every element has to be 0, I would say. Okay, but remaining these has to be 0. Condition is I should be greater than 0. Whenever I is greater than 0 in Aij, that means this number is greater than this number, then this number will be 0. How I am saying so? See, this is 3 cross 3 matrix. This is a triangle kind of, we can see, no? This is triangle, upper like diagonal if you say. So this is kind of a triangle only. Alright, so that means upper should be there, down should be zeros. Okay, this is just a way to remember. Now what does it mean? See, I mentioned first number. Suppose this I am talking about 2 and 1. I is greater than j. This will be 0. This is A22. I will be equals to j. This can't be 0. So now I'll take 3, 1. This number is again greater than 1. 0. 3, 2. First number is again greater than second one. So again it will be 0. So this is nothing but what? A21, A31, A3. Alright, this will be 0. So this condition is satisfied. Like this is a definition only. I'm just telling you why I is greater than j I have written. Next. Similarly, if I talk about lower triangular matrix. Lower triangular matrix name is already there. So down elements will be there, but up, suppose if I'll write this A, B, C, D, E, F, but this will be zeros. Alright, here condition is J should be greater than I. Aij equals to 0. Okay. We'll do one point now. Now this number is what? First row, second column. That means A12. J is greater than I. So this is your. Similarly, A13. Similarly, A23. A13. A23. Next. Next, I am going to talk about trace of a matrix A. This is very easy. Trace of A. Next topic, I would say. Simple topic. Suppose the elements are of this kind. A, B, C. Rest anything is there. Suppose E, F, anything. G. Anything is there. Any matrix is there. These are the diagonal elements. So trace of A, this is the way to write. Trace of A is equals to the sum of all the diagonal elements. Sum of all diagonal elements. Okay. So this is nothing but what? It is coming out to be A plus B plus C. Here. Now I'll do another topic as well. This was a trace of matrix. Now I'll do another topic, that is equality of matrices. Equality of matrices. Suppose one matrix is A, where order is, or where matrix is of the form Aij, order is M cross N. Alright. Another matrix is B, Bij, that means elements will be of the form, they are both are different matrices right now. So for equality, I'll tell you the condition. If it is satisfying both the conditions, two conditions will be there. If it is satisfying both the conditions, that means these two matrices will be equal now. That I'll tell you later. But right now I'm writing different. Now, what does it mean? Two conditions. Two matrices to be equal. First condition is order should be same. Okay, first thing, so they should be comparable. We can compare the matrices. If suppose this is 2 cross 3 and this is 3 cross 2. Okay, only 2 rows are there, 3 rows are there. You can't compare, no? So we can't say anything whether they are equal or not. Of course, we will say they are not equal only. Alright. So first condition is order should be same. If it is not there, equality will not happen. Second, corresponding elements should also be same. Corresponding elements should be same. I'll tell you the meaning of corresponding. Should be equal or same, you can say. Now what does it mean? First condition means, suppose I'm taking a matrix 1, 2, 3, 4. Order is 2 cross 2. Another matrix if I am taking as 5, 6, 7, 8. Order is 2 cross 2. Order is 2 cross 2. Are these two matrices equal? No. So if one condition is also satisfied, we cannot say the matrices are equal. Order is same, okay, fine. But corresponding elements are not equal. 1 is not equals to 5. Corresponding means what? First place, first place. First row, second place. First row, second place. Second row, first column. I'm using all the different words. Anything which you are understand. Second row, first column. Second row, first column. Second row, second column. So neither of them are equal. Okay, so I'll say these two matrices are not equal. Similarly, if I'll see, or if I'll talk about another example, 1, 2, 3, 4, 2, 3, 4, 1. Order is same. 2 cross 2, 2 cross 2. Elements also I can see the same elements, but corresponding elements are not same. See, corresponding means what? What I told. First row, first column. First row, first column. 1 is not equals to 2, no? So Again, these two matrices are also not equal. Simple. I hope I'm clear till this part. Just have a look. Okay. We'll proceed. Next, the very important topic, algebra of matrix. Algebra, name is depicting itself. We are talking about addition, we are talking about subtraction, we are talking about multiplication, but we are not talking about division right now. Algebra of matrix. Algebra means first I'm talking about addition. Then I'll talk about subtraction. Then I'll talk about multiplication. Addition and subtractions are very easy. Very, very, very easy. Simply you have to subtract and simply you have to add. Nothing you have to do. No rocket science. Little multiplication we have to calculate something. Okay, that I'll tell you. That is not complicated. That is not difficult. But you have to perform some steps over there. Addition. Suppose two matrices I am giving. 1, 2, 3, 4. It is not necessary that it should be in the continuation. No, any matrix you can take. Suppose I am taking 1 minus 2. Okay, we can take this matrix. But right now I am doing with the all the positive numbers. Okay. I'll do with the negative numbers also, no issues. Second matrix is suppose 2, 4, 6, 8. Randomly I have taken. It is not necessary that it has to be the multiple of it. No, not at all necessary. Just I'm keeping the random examples also, and I'm telling you it is not necessary. Nothing is necessary. The condition which is necessary is order should be same. Order should be same, then only addition and subtraction is possible. For multiplication also, order, it is not necessary that order should be same. One more condition is there that I'll tell you. But if your order is same, then also multiplication is possible. Wait, I'll tell you. Now addition means what? Plus sign. Here condition is order should be same. Now we'll add the only corresponding elements. Corresponding elements we have to add. 1 plus 2. Corresponding elements. No? Now this 2 and 4 at the same position. 2 plus 4. 3 plus 6. This step, when you will be pro in it, no need to perform this step. Okay, just this is the beginning, that's why I'm doing this step. Otherwise, no need. 4 plus 8. Okay, 1 plus 2 is what? 3. 2 plus 4 is 6, 9, and it is 12. So again, when you will see order is coming out to be same. Of course, order will come out to be same. We have not we have not any done the altercation or something like. We have not done anything with the order. Only we have added the elements, not only elements. We have added the corresponding elements. Here. Next, similarly, I'll do subtraction. Subtraction, simply same thing. Order should be same. Corresponding elements we have to subtract. Suppose I am taking any matrix 1, 2, 1, 5. Order is what? 2 cross 2. Okay, I'll take one example. 1, 3, 5, 6, 9, 3. Order is how many rows? 2 rows, 3 columns. Is subtraction possible? No. See how. You will subtract these two numbers. Okay, correspondingly. Okay, you will subtract 2 and 3 also. But what about this 5? Don't write only minus 5. No. So, subtraction is not possible. Is not possible as order is not same or order is different. Alright. So I'll take the two matrices which are having the same order. Randomly 1 2 1 5. Order is what? 2 cross 2. Subtraction I am doing with 0, 5, 8 and 3. Randomly. Now subtraction is possible as the order is same. Subtraction is possible. So what does it mean now? Corresponding elements we have to subtract. 1 and 0 at the same position. 2 and 5 is at the same position. 1 and 8 at the same position. 5 and 3 is at the same position. Order is 2 cross 2. 1 minus 0, 1, 2 minus 5, minus 3, 1 minus 8, minus 7, 5 minus 3 is 2. So the order is 2 cross 2. Order remains same. Order will remain same. This is the subtraction of two matrices. See, these things, directly question will not come. Subtract two matrices in JEE Mains. Everyone will crack now. Of course. But if you will not do the basic thing, how you will do the big question? Of course, JEE Main question means what? Few steps you have to perform. Okay, few concepts you have to apply. So this is just a concept only, no? Either this concept can be applicable or some else concept, suppose trace of a concept. So first we'll do all the concepts, understand the concepts, meaning of the concepts. Then you will realize how to apply those concepts. Alright. Without knowing how to climb, how you will climb the stairs? Of course, you should know that you have to lift your leg, then only you will climb the stair. Okay, so step by step. So these are the concepts. Now comes your multiplication. That is interesting also, little calculative, okay, but interesting one. So just you have to pay attention to it. Multiplication of two matrices. Now singular is matrix, plural is matrices. Okay, suppose any matrix I am taking. 1, 0, 3, 2, 5 and 6. Order is what? 2 rows, 3 columns. Okay. Alright. Another matrix if I'll take as 2, 9, 8, 3, 6, 6. Elements can be same also. It is not necessary. Nothing is compulsory. That only this has to be the matrix, then only it is possible. No. But one condition is there for this. Now see that condition. This is what? 3 rows, 2 columns. Okay, so 3 rows, 2 columns. Now condition is if I am doing AB, that means first matrix is A and second matrix is B. So first matrix column and second matrix row should be equal. Repeating. First I have taken A column, B row. Number of rows, number of columns. Okay, so A का number of row should be equal to B का number of, sorry, A का number of column should be equal to B का number of row. Second number should be equal to first number. Anything, any language you understand. Alright, shall I start? Now, when you will multiply, no, you will see one thing. You will get a matrix of 2 cross 2. The numbers which are left, no, that matrix you will get. How? That I'll tell you. Alright, now see it very carefully. See, as I told you, which matrix you will get at the end? 2 cross 2 matrix you will get. That means which elements you will get? A11, A12, A21, A22. Okay. Or I'll write AB1, AB12, AB21, AB22. Okay. Or you can write C11, C12. No issues. Like we don't have to focus on that part. The main thing is we will multiply first row and first column. First row with the first column. 1 1 means first row with the first column. I will multiply correspondingly, but 1 will be multiplied with 2. Okay. 0 will be multiplied with 8. Inside plus sign will come. 3 will be multiplied with 6. This is first row is getting multiplied with first column of the next matrix. Similarly, what does it mean? First row, second column. Okay, second column. Now first row, 1 will be multiplied with 9. 0 will be multiplied with 3. And 3 will be multiplied with 6. See it once again. It is not completed, I am doing. Now what does it mean? Repeating. First row will be multiplied with first column. First row only will be multiplied with second column of the next matrix with which we are multiplying. We will multiply the elements and plus sign will be there in between. Next, what does it mean? Second row, first column. Now this is your second row. First column is already there. So 2 into 2 plus 5 into 8. As we are proceeding to the next element, we have to proceed to the next element. Now 6 will be multiplied with 6. Okay. Similarly, second row, second column. So 2 into 9, 5 into 3, 6 into 6. Okay. Now I can have the next page also, but I don't want to have actually, because these calculations we have to see now, so I'm writing it here. 1 2 is a 2, 0 8 is a 0, 3 6 is a 18. Of course, this step you can skip, but when you will be through with the concept, after doing so many questions, this step is not needed. We can write it directly also. Okay, this if we'll do it in our mind, but depends where you are writing. So if you are writing it for CBSE, then you have to perform the steps. You have to write the steps also. 9 ones are 9, 0 into 3 is 0. 6 3s are 18. 2 2s are 4. 5 8s are 40. 6 6 are 36. So correspondingly I am writing 9 2s are 18. 5 3s are 15. 6 6 are 36. Of course, order is nothing but 2 cross 2. So 2 plus 18, 20. This will come out to be 27. 18 plus 9, 27. 44. It will come out to be 80. And this will come out to be 13, 19, 60. 2 cross. Here, repeating again. Whenever two matrices are given and we have to find the product, number of column should be equal to the number of row. Depends upon the order, which order we are multiplying. AB is not equals to BA. Okay. Two matrix. It is not necessary that AB will always be equals to BA. That is particular cases that we'll discuss later on. It is not necessary. So answer may vary. Answer will vary in fact. So now this the number of column should be equal to the number of row of this. We'll write now which two numbers are left? 2 and 2. That we'll write. First row, first column, first row, second column, second row, first column, second row, second column. This is the way to write. So now we'll multiply in this order only. First row will be multiplied with first column, first row will be multiplied with second column. Second row will multiplied with first column, second row will multiplied with second column. Okay, that was I have done. Add them and get the answer. All right, just have a look and then I'll proceed. The same example if I'm taking, I'll show you that AB is not equals to BA. How? That will tell you. Which two matrices were there? A was 103, 256, 103, 256, and B is 298366. 29836. All right, earlier we did A into B. Now we will do B into A. The order was, or order is 2 cross 3. Order is 3 cross 2. Now BA. BA means what? First we'll keep the elements of B. 298366. Then we will multiply the elements of Then we'll keep A matrix 1 0 3 2 5. First we have written B, then we have written A. Now this is what? 3 cross 2. This is what? 2 cross 3. Number of columns should be equal to number of row. First condition is satisfied. Okay. So now when we will multiply B and A, order will come out to be 3 cross 3, and when we did AB, order was 2 cross 2. First thing, so this is also not equal only. So anyhow answer will not come out to be equal. Okay, but I'll tell you how. Now 3 cross 3 answer will come. 3 cross 3 will come. So I'm taking C11, C12, C13, C21, C22, C23, C31, C32, C33. I'm not taking A and B because A will take for this, B will take for this. So AB we have to take, but instead of writing AB, I am taking C. This is not anything compulsory. Alright. Now what does it mean? First row will be multiplied with first column. First row will be multiplied with first column. Okay, we'll do 2 into 1 plus 9 into 2. Now first row will be multiplied with second column. First row 2 into 0 plus 9 into 5. Now first row will be multiplied with third column. First we have to deal with all the first rows, and then we'll proceed first column, second column, third column. If fourth column is also there, you can have it in the first column. So 2 into 3 plus 9 into 6. Next, now second row, first column. Now we'll see all the second rows. 8 into 1 plus 3 into 2. You will see one thing, this 1 1, this 2 2 will remain same every time. Okay. 8 into 0 plus 3 into 5. Similarly, 8 into 3, second row, third column I am multiplying now. 8 into 3 plus 3 into 6. Okay. Third row, first column. Third row, first column. 6 into 1 plus 6 into 2. 6 into 0 plus 6 into 5. 6 into 3 plus 6 into 6. That means third row, third column. Now we'll multiply and then we will add. 2 ones are 2, 9 twos are 18. 2 0 0, 9 fours are, 9 fives are 45. 2 threes are 6, 9 six are 54. 8 ones are 8, 3 twos are 6. Zeros, 3 fives are 15. 8 threes are 24, 6 threes are 18. 6 ones are 6, 6 twos are 12. 0 and 6 fives are 30. 6 threes are 18. 6 six are 36. If you want to add 0 plus, you can write it here. No issues. But anyhow, answer will come out with that only. That's why I do it that way. Instead of using the next page, because of the calculation here, so I am writing on the left side. 2 plus 18, 20. 0 plus 45, 45. 54 plus 6, 60. 14, 15, and then it will come out to be 42. 6 plus 12, 18. 0 plus 30, 30. And it will come out to be 54. 18 plus 36 is 54. Now we will compare. See, this is B into A. Matrix has come out to be 3 cross 3. And when I multiplied the same matrices and I took the multiplication or product as AB, the matrix was 2 cross 2. One matrix is 2 cross 2, another matrix is 3 cross 3. First, the order is also not same. Second thing, elements are also not same. Here elements are here elements are 20 and 27, 80 and 69. Okay. And in the next slide, when we did B into A, elements are 20, 45, 60, 14, 15, 42, 18, 30, and 50. So we have performed AB necessarily not equals to BA. I hope I'm clear to all. Just have a look and then we'll proceed. All right. Next, if I have to multiply a matrix with a scalar. Scalar means what? A single number only. Suppose any scalar is k. If I am multiplying any matrix with any k, this is a scalar multiplication. Okay. Now suppose A matrix is multiplication of matrix by a scalar. Multiplication of matrix by a scalar. Scalar means any constant number only. Any number. Okay. Anything. So suppose A matrix is 5, 0, 3, 2, minus 1, minus 2. Any matrix is like this. What is the order? 2 rows, 3 columns. Suppose K is 3 or 9, anything it can be. Randomly I'm taking 9 times of A. If I am multiplying any matrix, suppose with the 9 or this matrix only. So this 9 will be multiplied with all the elements. 9 into 5, 9 into 0. Of course, you don't have to stop. You don't have to do this step in the exam. No. But just to give you the idea or just to clear the basics first, I am doing all the steps. 9 into 3, 9 into 2, 9 into minus 1. These are the all elements, and I am multiplying with particular number, that is 9. 9 into minus 3. Order will remain, of course, same. 9 fives are 45. 9 zeros 0. 9 threes are 27. 9 twos are 18. 9 minus 1s are minus 9. 9 threes are 27. Of course, plus minus sign will come. Okay, so order will remain same. Now one matrix, one question I'll do on this basis. One question I am doing. So next question on this basis only. First, X matrix is given as 1A and 0, 1. All right. And it is also given as 3x minus of another matrix 2, 3, 0, 2, 2, 3, 0, 2. This operation, after applying this operation, answer is already given us as, we'll get 1, 3, 0, 1. Okay, now two things are applicable here. First, so I am multiplying any matrix with a scalar 3. Okay, so I'll do that. Now 3 will be multiplied with full matrix X. 3 ones are 3. 3 into A is 3A. 3 into 0 is 0. 3 into 1 is 2. Alright, minus this matrix as it is, 2, 3, 0 and 2. Answer we will get as 1, 3, 0, 1. Okay, we have to find the value of A here. The question is, we have to find the value of A here. Find A. Okay, so now order is same. This is 2 cross 2, 2 cross 2. So subtraction is possible. Okay, 3 minus 2, 1. 3A minus 3. 0 minus 0 is 0. 3 minus 2 is 1. Now equality also they have given. Another concept which is being used as equality of matrices. As I told you, one question they will give. It is not they will only ask you the addition and subtraction only. Concepts will be applicable there. So first concept is scalar multiplication, then is subtraction, and then is equality of matrix. Now corresponding elements are equal. You can see this 1 is equals to 1, 0 equals to 0, 1 equals to 1. So this means 3A is equals to 3 also. So this implies 3A minus 3 is nothing but equals to 3. Corresponding elements are equal in equality of matrices. This 3 is minus here on the right side, it will become plus. So it will come out to be 3A is equals to 6. This 3 is multiplied on the right side, it will divide. So A value we will get as 2. Just check. A value we will get as 2. I hope this is clear to everyone. Next question. On the same basis we'll do. One more question I'm doing on the same basis. Now the question is, pattern is little different, but steps depend. Whatever the operation they are asking us to apply, we'll apply the question and we'll apply the steps. Find the value of x and y. Find the value of x and y if question is 2 into matrix is 1 3 0 x plus y 0 1 2 equals to 5 6 1 8. All right, so we have to find the value of x and we have to find the value of y also. Whatever the operation they are asking, we'll do that. 2, any scalar, if I have to multiply with any matrix, what I'll do, this 2 will be multiplied with all the elements. So 2 into 1, 2, 2 3s are 6, 2 zeros, 0, 2 into x, 2x. Plus the other matrices y 0, 1, 2 will remain same. The other matrix, resultant matrix is 5, 6, 1, 8. Now we'll apply this operation plus corresponding elements we will add because this is also 2 cross 2, this is also 2 cross 2. Addition is possible. All right. So 2 plus y, corresponding elements 6 plus 0, 0 plus 1, 2x plus 2 equals to 5, 6, 1, 8. This order is also 2 cross 2. This order is also 2 cross 2. So equality is possible. But they have given they are already equal. So order is also same. That means corresponding elements will also be equal. Okay. So that means corresponding elements means what? 2 plus y equals to 5. This implies y value will come out to be 3. 6 plus 0, 6. 0 plus 1, 1. So which is left? 2x plus 2 equals to 8. This 2 will go on the right side. It will become 6. X value will come out to be 3. So x is also 3. Y is also 3. So today, this all we have done, and tomorrow we'll do some other topic. I hope everyone have understood. Thank you so much.
Good afternoon, all. Hello, everyone. So it's my name is Gautam, and I take botany here. And we have already started one class before that. So the chapter which we are going to deal in this this session is cell, the unit of life. So basics of this introduction we have already discussed in first class. So the continuation of that we are going to discuss it now. See, in the last hour, what we have discussed, and this what we have discussed is that is previous year analysis. Also, we have discussed. So, how many questions has been asked from last year, like past 10 years data? It is there. So, these are all previous year questions analysis. So, these many number of questions it came from this particular chapter, and this is topic wise analysis. And the last concept what we have discussed is there, no, that is cell introduction part and cell theory. So that cell theory and cell introduction part, from that these many questions has been specially like an overview of the cell. Before that it is there, no, 6 questions they have from just one para there. And continuation of that, see what we have discussed is what is a cell, and the definition of the cell, and the functions of the cell, and cell theory. So that we have discussed in the last class. So if you have any doubts, you can just comment your doubts are in the chat section, so that I can see and clarify there. So cell, all the organisms, it is made up of cells, we know that. Even taking from a single small prokaryotic unicellular organisms to and huge multicellular animals or plants. So all the organisms are made up of cells or products of cells. So how do we got to know, and on what basis or what on, so in what confidence I am speaking this much? Because of the scientists who gave cell theory, who formulated cell theory and all. So we know that the cell theory has been formulated by two scientists, that is Schleiden and Schwann. So in the year of 1838, Schleiden has who is a German botanist, who gave a statement that the cells, plants are made up of different kind of cells and different kind of tissues. And in 1839, in a 1 year after that, Schwann, who is a German zoologist, who gave a statement of the animal cells are covered with an outer layer that is nothing but uh, today what we refer it as a plasma membrane. And next to that, he also gave one more statement. He concluded that the plant cells has one more outer layer to that, that we call it as cell wall. So he concluded that even being a geologist, he worked on the plant cells as well as, and he gave that statement. So regarding this, he gave an hypothesis also.